Hi, everybody. Hopefully, everybody's having a great day. Um, that last experiment, I'm thinking maybe why I was having a little trouble. It could have been a bad relay. Who knows? It's a lot. Sometimes you get bad things. But moving on to today's lesson, experiment. Lesson 31, stepper motor with Arduino. Uh, it's supposed to be fun and easy, and I thought maybe I was having trouble, but no, it's just because this motor is much more quieter and it moves slower. And it just functions different because this is a bipolar motor versus a unipolar, which means it's got two separate coils, four leads all together, but two separate coils with two leads each, and that makes that causes the rotation. But that's not all of it. Here it is. It's as you can see, it's a little different. It's running now. You can't even hear it. It's so silent. Um, Converts electrical pulses into discrete mechanical movements. It's related to the frequency of the impulses, and length of rotation is directly related to the number of impulses applied. It can accurately advantages. It can accurately control in an open loop system. That means no feedback information about position is needed. And it eliminates the need for expensive sensing and feedback devices such as optical encoders. Optical encoders are, you might see them in your radios and things, the little dial that you have. It has a light sensor and it detects if it moves. I only know this because my extra class ham radio license I had didn't learn about it. But your position is known simply by keeping track of the input step pulses. Here's the specs on the motor. Here's a wiring diagram. Now this is what I was saying. Two separate coils, four leads all together. This controls this part and that controls that part. So it usually has four wires coming out of it, unlike unipolar steppers. Bipolar steppers have no common center connection. This is no common center connection because they have two independent sets of coils instead. Frankly, I don't think that limit you having just two coils. I think you can have more than two coils, but just have more leads to connect to. That's my own thoughts on that. If you don't have it attached correctly, then you have no continuity. So if you do a ohm test or a beep test with your meter, you won't hear anything. But if you do connect it between the 2 points, here's your inductors that cause the rotation, then you will hear some beeping from your ohm meter or when you beep it out, which is a quick way to find out what leads go to what. Okay, let's go forward. This little gizmo is your ULN 2003 driver board, which helps make all the magic happen, along with your the simplest way of interfacing your unipolar stepper to Arduino is to use a breakout, which is this, a transistor array chip. Contains 7 Darlington transistor drivers, and it's somewhat like having TIP1 transistors all in one package. It dissipates the voltage spikes when driving inductive loads to control the stepper, applying steppers to the coils in a specific sequence. Now, that specific sequence, that wording is essential because it's kind of like going down a step here. It goes one at a time. You have one up here where it restarts the whole cycle again. So it goes through here. Then once it's done, it's already beginning to start going again. So that's what allows the motor to have its motion, its movements. So here's your ULN 2003A. Here's to your Arduino. Here's to your stepper motor itself. And here's a ground here, but you're drawing power with this red field, so it's both coils that switches the inductions on and off, depending on the direction. Okay. And here's how it looks. So again, I mentioned about that red. It says yellow here, but it goes red, and then there's a little point where it goes to in the middle of that coil, and then it goes in that coil. So depending where the power is going on, that's how your coils are engaged, or turned on, I guess I should say. Turned on might be a better word. And here's how it looks, how I wired it and everything, or they showed a schematic. And there's a program that you upload, and I did that. You have to excuse me, my experiment's getting jeopardized a little bit. But let's look at the experiment. Okay, here's that ULN 2003A. It's plugged to this motor if we can find it. My daughter's fidget toys. But anyway, you can see the rotation going both ways. I have to bring it close so you can see what's going on. It looks like my board's still plugged in, so that's good. I had to use my molded by wire, so I had to make sure I hooked everything. Miraculously, I hooked it up correctly, so that's good. But that's all I have, everybody. Have a great day. Be safe, and talk to you next week. Bye.